I don't know what you think. All right, and we will start the slideshow from the current slide, which is example 1. Any questions on what we've covered so far? Just a quick review. We started in 1.4, did 1.4, 1.5, 1.6, gave you the quiz that covered those 3 sections. We finished 1.7, we're on 1.8. When we finish 1.9, we'll have the test on chapter 1. Okay? So any questions on anything we've done so far? And by the way, the papers can be turned in any time. I've received 1 out of my second biggest class. 1 paper so far. I'm glad to have that, but please don't let time sneak by. Okay. So any questions? Okay, example 1. These are pretty simple things. Okay. And Ebony? Huh? Courtney. Okay, sorry. I knew that's where you usually sat, but okay. I just called her as you were coming in. Okay. Remember, these are the pretty simple things in combinations of functions. Given that f of x is equal to 2x plus 1, g of x is equal to x squared plus 2x minus 1, it says find f plus g of x. Okay? Now, how do we go about doing that? A little out of it. Okay, not yet. We want to first find f plus g of x. Okay, so we write down 2x plus 1. That's the f of x plus x squared plus 2x minus 1. Okay? Now, basically what we're doing here, folks, I probably should do it. Since you piped in, I just did what you told me. But f plus g, the sum function, is simply f of x plus g of x, just like it appears. And that's what we did. Here's your f of x, there's your g of x. We're adding them together, and what do we get? X squared plus 4x, and that's it. All right. And this is? Second? Sydney, got it. Okay. All right, good deal. So there's your sum function. X squared plus 4x. Now, we're doing example 1, bottom of page 76, chapter 1, section 1.8. Okay? And this, by the way, is your f plus g of x. Now, what it says, evaluate that sum when x is equal to 3. So what we're looking for now is f plus g of 3. And what would that be? And how would you do it? Okay, so that'd be 3 squared plus what? No, 4 times 3. Plug in 3 everywhere you see an x here. We plug in a 3. Okay? So 3 squared plus 4 times 3. Everywhere you see an x here, we plug in a 3 instead. Now do that calculation. What does that give you? 3 squared is plus equal 21. Perfect. Okay? Now, just for funsies, let's see what we get when we plug in f of 3. What would that be? Yeah. 2 times what? 3 plus 1, and what would that be? 7. Okay? What happens if we plug in g of 3? 9. 6. Okay, and that would give us? Say again? Really? Say again?
9 minus 5 is 4.
Okay. But it's 9 plus 5. Okay. Cleverly disguised. Okay. And what is it? 14. All right. Hike. Okay. And what is 7 plus 14? 21. Sure enough. Alpha G of 3 is the same as alpha 3 plus G of 3. Right? So, guess what? Whichever is the easiest way to do it that way. If finding the sum function first and then plugging in you find easier, do it. If, however, it's easier to plug in and then add, do it. Both of them work. That's what that tells you. The sum of two functions of x is the sum is alpha of x plus g of x. All right. Let's see how they did it, just to see. Probably not as neatly as y'all did, but let's see. Okay, so they first write down f plus g of x is alpha of x plus g of x, which is what we wrote down. And then we plugged in alpha of x is 2x plus 1 plus x squared. G of x is x squared plus 2x minus 1. Now, they did it in color, in parentheses for emphasis, okay? But remember, a parenthesis preceded by nothing really doesn't do anything for you. You can take those off, and a parenthesis preceded by only a positive sign, that doesn't do anything for you. You can take that off, and that's why we left them off before, okay? And that, when you combine like terms, you get x squared plus 4x, right? Now, the second part says, when x equals 3, the value of that sum is f plus g of 3 would be plug in 3 squared plus 4 times 3, and that gives you 21. Perfect. Any questions on that? Now, we did a little bit more, but they didn't, okay? They're pretty lazy. All right. Now, they're skipping example 2, 3, 4. Yeah, 2, 3, and 4. So let's do that. Okay, given alpha of x, same thing. G of x, same thing. This time we want f minus g. F minus g of x. And someone tell me what you think that might be. Say again? In terms of f and g. Okay, yeah, you're jumping a little ahead. F of x minus g of x. That's what the difference function is. And that's what Danielle is. Okay. All right, is anyone else coming in since I called roll? I was sort of paying attention to the board. I may have missed you. All right, good deal. Okay, we're on example 2, top of page 77, chapter 1, 1.8, section 1.8. Okay, so what do we do next? Say again? We might want to do it down here. Okay, and what's f of x? 2x plus 1, I'll put parentheses, so that doesn't help us much, minus x squared plus 2x minus 1. There you'd better put parentheses, because that's no longer a plus sign, it's a minus sign. So the only time that you can forget about parentheses or when there's nothing in front of it, like here, we can take those off, but here, this indicates we have to distribute what's outside across the inside. And when it's a plus 1, yeah, that doesn't distribute any, I mean, yeah, 1 times anything is itself. So, what do we have here? 2. Say again? I thought you said 2, sorry. That's, yeah. 2x plus 1 minus x squared minus 2x plus 1. All right. And this is, name please? Trey. Okay. All right. And Ashley, got it. got to find you there. There you are. All right, good deal. Anyone else come in since I called roll? Okay. All right, now what do we do? Combine like terms, and what do you get? Negative x squared plus 2. Because it's plus 2x minus 2x, they add to 0. So that's what we got. You could write it 2 minus x squared. It doesn't really matter. And then it says, then evaluate the difference when x is equal to 2. So what's f minus g of 2? What would that be? What would that be? Minus 2 squared plus 2. All right, now this is an important step here. What do you do next? Say again?
Are you asking what we did for negative g2?
Yeah, negative 2 squared. That's what I'm asking. Negative 4, very good. Okay? Plus 2, and that equals negative 2. Good. Now, the reason I paused there is that, remember, this is not negative 2 squared, it's negative 2 squared. You always do exponents before you do additions or subtraction. A sign change, negation is like a subtraction. If there was parentheses around there, you do parentheses first, then you square, so therefore you square that. This doesn't have the parentheses, so that is negative 4. Now, if you recall, what was f of x? Oh wait, we didn't do that, did we? Let's go back and check it this way. What's f of 2? 5. Okay, 4 plus 1 is 5. What's g of 2? 4. Say again. Plus 4. Minus 1. That would be 7. And what's 5 minus 7? Negative 2. Yeah, very good. So sometimes sort of easy to check these things too. All right, any questions on a difference function? All right. Let's move, if there are no questions, to example 3. Okay, this time they change our f's and g's. Okay, this time f of x is going to be simply the squaring function, x squared, and g of x is going to be x minus 3. The question here is find fg of x. And what's the definition of the product of two functions? The product of the two functions. That would be f of x times g of x. Okay, pretty simple. And what was your f of x?
X squared.
X squared times the g of x, x minus 3. And when you do that, what do you get? X cubed minus 3x squared. All right, that was pretty easy. That is the answer for the first part. Find f of g of x, fg of x. Okay. Second part says, mark Chelsea here. Okay. All right, anyone else coming since the call roll? Okay. The second part says, evaluate the product when x is equal to 4. So we're looking for fg of 4. And how do we do that? 4 cubed minus 3 times, second, 4 squared. Okay? Anyone happen to know what 4 cubed is? 64. Okay, 64 minus Say again? I'm not sure. It's not. Okay. 4 squared, yeah. 4 squared is 16. 3 times 16 is 48. Okay. And what's that difference? 16. Okay. You were giving me the answer for all of it. Okay. 16. Okay. Well, let's just go back and check and see what alpha 4 is. What was that? Okay. That's big. Huh? Okay. Show us. Okay. Good. All right. What was that? Alpha 4. We're doing example 3, page 77, chapter 1, section 1.8. What's alpha 4? 16. 4 squared is 16. What's g of 4? 1. And what's 16 times 1? 16. Yes, it works. Okay. All right. Let's move on to example 4. Now, why in the world they didn't do these that were a little more involved? They only did the very simple one on the slide set. These are a little more involved, okay? F of g of x and g of f of x. We want to find both of those for the functions. F of x is equal to the square root of x, and g of x is equal to the square root of 4 minus x squared. Okay? And then we'll find the domains of f of g and g of f. Okay. Now, time out. I don't like the way they're saying do the order of this. When you write down a function, whether you write it down or not, I think it's a really good idea to at least mentally or physically write it down or note what the domain of that function is. So let's start with the f of x. What's the domain of that function? Second? Absolutely, because anything in a radical has to be greater than or equal to 0, and the only thing in there is x, so the domain here is x greater than or equal to 0. Very good. How about g of x? This is going to take a little work, but not bad. What's that? Okay, let's just take it one step at a time. What's inside the radical? 4 minus x squared. And what do we know about that? Got to be greater than or equal to 0. Okay, let's do it that way. Okay. Now, the safest bet here, if you had that as an equation, not an inequality, and I said solve that, how would you do it? What would be your first step? Okay. I like better, what's the F word? Factor it. Yeah, let's factor it. Okay, now you wanted to move things to the other side? Okay, the whole thing, right? Okay. Now I can see where she's going on that. She's wanting to subtract 4 and add x squared to both sides, right? Okay, no, that's what he said too. And that is a legal move, but it may get you in trouble, is what I'm saying. So I like to try to keep you out of trouble, okay? That's my job, okay? So let's see if we can keep you out of trouble. What's the F word? Factor. And how can we factor the left-hand side? Okay, I want a good answer. Okay.
Can you take the negative sign out? Like factor out the negative sign out?
All right, now that is another good idea, okay? She's saying let's factor out the minus sign. There'll be minus times what? X squared minus 4. We haven't changed a thing. We just factored out the minus sign, so that's good. That's still greater than or equal to 0. Okay, got it? Okay, this will be what? I can't hear.
Negative. I don't know. Put X right there.
Okay, X.
Put an X on the other side.
Okay. Second. Plus 2 and minus 2. Check it and see that sure enough is right. Now you could have left it in there the other way and done it there. That's fine. Okay. Now with that minus sign out front, we got a little head scratching to do. Okay? You know this is going to negate whatever's here. But this has to be greater than or equal to 0. So that means whatever's here has to be negative. Because you're going to negate it and make it greater than or equal to 0. Okay? So you got the product of two things being negative. What does that mean? Okay, one of those got to be positive and one's got to be negative. For the product to be negative, you got to have one positive and one negative. Okay, so let's take it however you want. Let's start with, we got two cases to consider here. Told you this is a little more involved. Okay, let's start with x plus 2. What do you want it to be, positive or negative? Positive. So if it's positive, that's greater than or equal to 0, that means that x minus 2 has to be less than or equal to 0. Negative, right? So let's solve those two. Okay? What would you do to the first one? Say again? Okay, you may be saying right, I just can't hear. What are you doing? Subtract 2 from both sides, right? That legal in most states? Okay. And what do you have? X greater than or equal to negative 2. And at the same time, what do we do on the other one? Add 2 to both sides, and that gives us x is less than or equal to positive 2. Okay? Now, I like visuals pretty well, so let me draw a number line here. Okay? That's the ugly number line. There's 0. There's 1, 2, 3, 4, 5. Negative 1, 2, 3, 4, 5. So here is negative 2, and there is positive 2, and this says x's have to be greater than or equal to, that's why I colored it in, negative 2, but they also have to be less than or equal to positive 2, so there is the domain of that. Okay? Now we have to consider the other case. In this case, let's let this one be negative and that one positive, right? So either one of those would work, right? So let's do that. It's either this or x plus 2 less than or equal to 0, and at the same time, x minus 2 greater than or equal to 0. Okay? What do we do here? First equation, inequality, subtract 2 from both sides, and that gives us x is less than or equal to negative 2, and at the same time it's got to be, say again, add 2 to both sides, right? And that gives us greater than or equal to positive 2. Okay? Give me a different color so I can use the same line. Give me a color.
Green.
Green. Light or dark? Dark? Okay, we'll go with dark green. So this is x less than or equal to negative 2. There's equal to negative 2. Less than is going to be that way. Okay? And there's x greater than or equal to positive 2. There's positive 2. Greater than is going to be that way. Is there any way those can both be true at the same time? no. You can't be less than -2 at the same time you're greater than +2, and that was an and. They both have to be true. So this situation is not allowed. This is what we got. There's the domain of that function, -2 to 2. Okay. That's just to give you the domain of g of x. So basically we say, no, these won't work. These won't work. Okay, that's your domain. All right, okay. We got the domain here. Let me go back to dark. Okay, so on this one we say, do you like it in interval notation or do you like using the inequality signs? I don't care. You tell me. Inequalities or intervals? Someone say something.
What's your question?
Do we want it in inequality signs, the domain, or do you want it as an interval notation? Second? Interval. Okay. So this one, how would we write this one in interval notation? This one right here. Second? Yeah, okay. Got it. Start with a bracket. 0, comma, positive infinity. Parentheses. Got it. Okay, how do we do this one? Oh, there it is right there. So this one is this one right here. Okay, so that would be -2 to 2. That's the interval for that. All right. Can I erase some of this that was all sort of scratch work to show you what was going on? My eraser's not coming up. So let's, since I've already rewritten this and that.
Don't erase them.
Okay, I won't. Okay. All right, I stopped. Maybe not quite in time. I think I missed the X there. Okay, so let's do the quotient function. What's the definition of this? It's pretty simple. F of x divided by g of x, right? Okay, now let's plug that in. What's your f of x? Square root of x divided by 4 minus x squared. Okay? Now, that would be an answer, except we have to, okay, time out again. Anytime you're dealing any of your combinations, addition, subtraction, multiplication, division, you have to have the same domains. So what's in common between this domain and that domain? And this would be true for addition of functions, subtraction of functions, or multiplication of functions. What's in common between those two? Maybe I should have left that line up there. Say again? Okay. Actually 0 to 2. That minus 2 to 0, can't use that anymore. Fails here. So you're starting from 0 to 2 in bracket. So this function, at least on the surface, you know it has to be 0 to 2, right? Or at least that's where we think. Okay? That takes care of this and that, the domain of both of those. But we've got a problem, Houston. What is it? We've also got a variable in the denominator. What can that never be? It can be negative. Well, it can't be negative from what we did before. But in addition to what we did before, what can this never be? Once you put it in the denominator, it can't be 0. And remember, before we did allow zeros, right? Now we can't allow 0. What would make this 0? If you plugged in 2. So now we have to disallow 2, which means we take off the bracket and put in a parentheses. Okay? Now there's our domain for the quotient function. Yes?
Okay, so when we were finding the domain for g of x, and we got x plus 2 is greater than or equal to 0, then x minus 2 is less than or equal to 0, why do we put the less than in the x minus 2? Like, why would we put that?
You mean these over here?
Yeah.
Okay, we tried
The other one. The one
this
beside
one,
it.
this one right here. Oh, I lost the x. Okay. Is that what was bothering you?
No, why
No.
did you flip the signs on x is less than or equal to?
Okay. We did what y'all told me to. I was just doing what I was told, you know.
Yeah.
Not my fault. Okay. Okay. Here we had a minus sign. We knew these had to be different signs. So either this one's positive and that one's negative, or this one's negative and that one's positive. It just got to be different signs. Those were the two conditions. And then we solved the inequalities just like we had.
So
And
why
this-
did you have the one with the x, was that one wrong?
This one over here, everything's fine except how can x be less than negative 2 and at the same time be greater than positive 2? That poor little x can't be schizophrenic. Okay. Yeah, it's got to be, something that you can deal with. That's impossible. Okay? X can't be both of those. It can be both of these. But the first one didn't allow anything below 0, so you had to lose these. And you had to just go from 0 to 2. Inclusive, okay? So those two did that, but as soon as you put this in the denominator, whereas you could allow a 0 there, you can't allow a 0 here. So you have to lose the 2. So that changes that to a parenthesis. All right? That's half the problem, okay? Let's do the other half. Let's do g of f. G divided by f of x. What is that defined to be? This is the easy answer. It's real easy. G of x divided by f of x. Okay? And what's your g of x? G of x. Okay. The square root of 4 minus x squared over f of x f of x f of x square root of x. Okay. That is the answer to the first part of the question. That is what g divided by f is. Now we need to deal with the domain. Now remember our domain, we had assumed was going to be 0 to 2, but over here we had to disallow the 2. On this one we have to it has to be greater than 0. It can't include 0. So here your domain would be from 0 to 2. 2 is fine now. It's all right to have a 0 in the numerator. You can't have a 0 in the denominator. Okay? So this is your quotient function, f divided by g. There's your quotient function, g divided by f. Here's your domain, and you got this domain by looking at the domains of each of those separately and taking what's in common, 0 to 2 inclusive. And that's what you would have had, except you can't include the 2 here. You can't include the 0 there. So you lose the 2 here, lost the 0 here. Does that make sense? All right. And that one they decided not to put on the slideshow. Thank you very much. Okay. And if you check in the book, though, they got it right. Good for them. All right. And by the way, there's checkpoints after every one of these. If this is a little fuzzy to you, as soon as you get out of the classes today and have a chance, do those checkpoints. The audio video solutions are available at larsonfreecalculus.com. All right, sounds like a commercial, doesn't it? Okay. Brought to you by. Okay. Now we're going to composition of functions. I think we were used to adding, subtracting, and multiplying and dividing. We just weren't used to doing it with functions, but that wasn't that bad, was it? Okay? And by the way, let's just think back a minute. Addition of functions, it didn't matter what order you did. It didn't show that. Okay? Subtraction of functions, though, it would matter. because subtraction is not commutative. Multiplication functions, it wouldn't matter. Division, we just saw 2 different answers because division is not commutative. Okay. But now we're doing composition of functions. To me, this is something new. Have y'all run into this before, any of you? Composing functions? Say again? Okay. Let's see. Another way of combining 2 functions is to form the composition of one with the other. For instance, if f of x is x squared and g of x is x plus 1, then the composition of f with g is f composed with g of x. Okay? Now, we have a symbol for it. We're going to get to it in a minute. But here's how you read this. F of g of x. The parentheses, just read it as an of. Okay? And what you do, you start with the innermost function first. The g is the innermost function, so you plug in what g is here. Now you're doing f of x plus 1. Well, what does f tell you to do? What's the f function doing? It's squaring whatever's in the parentheses. Well, what's in your parentheses now? X plus 1, so you take the x plus 1 and you square it. There is the composition of f with g. Okay? So it's nothing too new. That composition is denoted by f circle g. Almost look like fog, and it does seem a little foggy. So it's red. But how I think of it, think of that O as the O for of. F of g. Alpha of g. If you think of it that way, you got it not. F composed with g or alpha of g. Okay? Now, so here's the definition. The composition of a function f with g is f composed with g of x is f of g of x. If you do it that way, it's almost sailor proof. We used to say that in the Navy, you know. You had to make all your instructions so not even a sailor could screw it up. Okay, so yeah, it's sailor proof. This is student proof. No, I know what it is. Okay, the domain of f of g of x. Ooh, now this may be something. Let's see where your x's are. That's your domain. The x's start out being the things that feed into g. So therefore, your x would be anything that g allows. It could be all real numbers, but if g is something like a square root or a rational function or something like that, you have to limit it. So it has to be that. But then not only that, the output for g becomes the input for f. So if anything, f can't accept some of the outputs of g, then you have to go back and limit the inputs of g so it doesn't give you those outputs anymore. So you see it's a little more involved. The domain of f of g is a set of all the x's in the domain of g such that g of x is in the domain of f. That's saying it one way. Now this is what they call a mapping illustration of functions. You start with your domain x, all the values of x. That's the domain of g. Okay? G maps this onto g of x. That's the range of g, but that range of g becomes the domain of f. Okay? So if any x's here won't work in g, they're already out of there. Okay? But if any of these in this range of g, which is the domain of f, if f can't accept them, then they're out of there. Then you have to back up and say, well, those x's that produce those g's, they're out of there too. So that's what we have. Most of the time, it's not that complicated. It sounds worse than it is. And this is f operating on g of x. F of g of x goes straight to there. Okay. So, any questions? A lot of blah, 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 right? Let's actually do some. They're not that bad. They're fun. Okay? Of course, all this is fun, isn't it? Okay. What do we mean by f composed with g of f? What does that mean? Define that for me. F of x is x plus 2, g of x is 4 minus x squared. What does f composed with g mean? F parentheses, g parentheses, x parentheses, parentheses. And what do? plug in the innermost first. So leave the f alone for now. Plug in what g is. What is g? 4 minus x squared. Okay? Now we use f. What does f say to do? Whatever's inside here, add 2 to it. Right? Whatever's inside here, the x, add 2 to it. So what's inside there? 4 minus x squared plus 2. Let's fix that. What would that give us? 6 minus x squared. There's f composed with g. Not too bad. Okay? And when you look at this, okay, domain of g, what? All real numbers. Range of g, basically going to be anything 4 and smaller. Okay? But who cares? What's the domain of f? All real numbers. So even though you don't have all real numbers coming in, it can take them all. So we don't have to worry anything about the domain or range of that. And looking at this, yeah, all real numbers that would work will be fine. Okay? So let's do the other one. What does g compose with f? What's that definition? G, parentheses, f of x, close, close. What do you do first? The innermost. So leave g alone for now and plug in what f is. What's f of x? X plus 2. And what does g tell you to do? You start with 4 and subtract from that whatever is in those parentheses, which is x plus 2 squared. Okay, we've got a little work to do here. Let's get to it. 4 minus, what's x plus 2 squared? X squared plus what? Plus 4x, excellent. Plus 4. Okay, now let's do our subtraction. What do we get? 4 minus x squared minus 4x minus 4. And what does that yield? Minus x squared. Ooh, I can't write. Okay. Continue. Minus 4x. There we have it. Okay. Now, what do you notice? Composition is a commutative even. Now, this is an operation. It's not a, it's a, but anyway, you can't change the order. F of g is not necessarily g of f. Definitely not. Okay, so you can't always. Now, time out. Occasionally, rarely, but occasionally, they will be equal, and when they are, you've got special functions. We'll get to that later. Okay? Next thing. What do we mean by g of f of minus 2?
G
Okay, say again.
G
Okay. F
negative 2.
negative 2. Okay? And what would that be? What's f of minus 2?
2 plus 2.
Say again?
G of 2 plus 2.
Isn't it minus 2 plus 2?
Minus
Okay, yeah. So g of minus 2 plus 2. And what's minus 2 plus 2? Say again? 0. And what's g of 0?
4.
4. You're absolutely right. Okay? Now, also, this was g composed with f of x, remember? So let's plug in a minus 2 there. G composed with f of minus 2, and that would be a minus, lots of minuses here, negative 2 squared minus 4 times a negative 2, right? Is that too fast and furious? Okay. I should have let y'all do that, sorry. Okay. All right. And what is, that would be a minus, what's negative 2 squared? 4. And what's minus 4 times minus 2? Plus 8. And guess what that is? 4. Yay. It works either way. Okay. So you can either compose the function first and then plug in, or you can plug in and do your composition there. That looked a lot easier to me. Thank you very much for doing it the easy way. Okay. So, any questions on that? Let's see how the book did. Y'all remember how we did? You got it down, most of you? Any can I erase it now, or is anyone still writing? Okay. Say again? Oh, you're still writing? Okay. Let me hold on. Have I covered too much here? Okay. Oh, don't do that. Okay. And you don't have to do it both ways. I'm just showing you both ways work. Okay. You know, some people still writing. Anyone still writing? No. Okay. All right. So let's see how they did. First, they did f composed with g, and they did it just like you did, f of g of x, and plugged in the g of x, f of 4 minus x squared. F said, take whatever's in parentheses, add 2 to it, 4 minus x squared plus 2, which is minus x squared plus 6. I wouldn't have written it that way, but that's fine. Okay. Then the g composed with f of x is g of f of x. This time you plug in the f of x first, g of x plus 2, and the g function said start with 4, subtract from it whatever's in parentheses, squared. We did it. We squared that binomial, and we subtracted, and you got minus x squared minus 4x. Note that in this case, and in most cases, but not all, f of g of x is not equal to g of f of x. In most cases, they will not be equal. The rare cases they are, you've got special functions. Okay? Now, the C part said plug that in. They plugged it in the hard way, unlike what you did, and that was negative 4 plus 8, which is 4. If you plugged it in the other way, you also got 4. Make sense? All right. Now, that was example 5. Where does this slide fit in? That's somewhere down the road, I think. Yeah. So let's back up and do, example 6. Whoa. Okay, whatever. Find the domain of f composed with g for the functions f of x equal x squared minus 9, g of x equal the square root of 9 minus x squared. Okay? We want the domain of those functions of f of g of x. So where would we start? And by the way, they said find the composition. They didn't tell us to. They just said find the domain. But let's do the composition. What does f composed with g of x? What does that mean? F, parentheses, g of x, close, close. And that would mean, do what? F of the square root of 9 minus x squared. Okay? And what does f tell you to do? To square that thing, which is, say again? Square root 9 minus x squared squared minus 9. What is the square root of 9 minus x squared squared? 9 minus x squared, okay? So that would be 9 minus x squared minus 9, which would be negative x squared. Now look at that and say, what's the domain of that? Looks like all real numbers, doesn't it? But it's not, okay? Because you have to start with the excuse me. You have to start here. X started here with the G. What's the domain here? Say that again. 9 minus x squared has to be greater than or equal to 0. Okay? Now, can you sort of think your way through that a little bit? What would that tell you? Say again? You can do the math. That's doable. But if you just think about that. It can't be greater than 3? No, it can't. You're right. If x is greater than 3, like 4, that would be 9 minus 16. That's a negative number. Wrong. So x has to be less than 3. From minus 3 to plus 3 in parentheses. You're absolutely right. Minus 3 to 3. See that? Anything less than negative 3, like negative 4 would be 9 minus 16 again. You can't do that. So it has to be between minus 3 and 3. X cannot be greater than, x squared cannot be greater than 9. So, okay. So that's one way to look at it. Okay? So between minus 3 and 3. You can go back and do your factoring and all that kind of stuff and look at the cases. That's what you're going to get. Okay? So if that's the requirement there, then g of x produces a positive number because that's a principal square root. You can put any positive number in there. You can put any number in there, but you're only going to produce positive numbers. So therefore, your domain of this still has to be that. Even though minus x squared doesn't care what you put in, but because this is where it started at, the domain has to be minus 3 to 3. Okay? And that's what they say too. All right, they even do a little graphic for you, graphical solution, which if you have a graphing calculator, you can do it too. There is a checkpoint there. Okay? Any questions on that? Okay. So in examples 5 and 6, you form the composition of two given functions. In calculus, it's also important to be able to identify two functions that make up a given composite function. For instance, if you have h of x is equal to 3x minus 5 cubed, that's the composition of two functions. What two functions would it be? And again, think of inner and outer. What's your inner function? 3x minus 5. Let's call that the g of x. And what's the outer function? The cubing function, x cubed. So therefore, the composition of f of x equal x cubed, that's the outer function. G of x, 3x minus 5, that's the inner function. So h of x is 3x minus 5 cubed, which is g of x, if you define that to be g of x cubed, which is f of g of x. Okay? Now, what we call this is decomposition of functions, okay? And we have just done that. We have just taken a big function and decomposed it. Now, I hope many of you will continue on to calculus. Why we need this on calculus is a handy-dandy little thing when you're taking derivatives called the chain rule. When you're taking a derivative of a composition of functions, you take the derivative of the outer function, then the inner function, and you go like that. So, you need to know that for calculus. So basically, to decompose a composite function, look for the inner function, okay? The inner sub, no, okay. and the outer function, the function h of x, would then be, if the inner function is 3x minus 5, the outer function was the cubic function, and then you can write h of x is equal to, whoa, they skipped right over. So let's decompose a composite function here. And guess what? There may be more than one way to do it. So let's do example 7. Okay? Here's your h of x is equal to 1 over x minus 2 squared. It says rewrite that as a composition of two functions. And I'll tell you right ahead of time, there's more than one way to do it. So you tell me what you would think the best way to do this. Or one way to do it. May not be the best way. Let's say first, look for the inner function. What do you think that might be? Say again? You may have said it, I can't hear. X minus 2. So you want that to be called what? G of x? X minus 2. Then what would your outer function be? No? 1 over x squared. That's it. You could have said the inner function was x minus 2 squared, and the outer function was 1 over x. That would work too. Okay? So there's more than one way to do it. You could actually make this a composition of 3 functions. You could make it a composition of the inner function there. The next, the intermediate inner function would be 1 over, to be x squared, and then the other one would be 1 over x. So yeah, you can do it as many times as you wish. Okay? They did it the way you did. Okay? Now, before we get to our application, do you want to hear a dumb story? It sort of feeds into decomposition of fun. It really doesn't, but it's a dumb story. You want one or not? I want to go. Okay, dumb story time. Any of you ever heard of Beethoven? I don't mean those big dogs. Okay, Beethoven, one of the world's greatest composers who ever wrote a lick of music. I rank him right up there. I love Mozart, but Beethoven right up there with it. His Fifth Symphony is probably the most powerful piece of music ever written, at least in my mind. Dun-dun-dun-dun, dun-dun-dun. You've probably heard it in many, many applications. Well, Beethoven, I think, was a pretty serious old dude. I don't know that for a fact. I haven't read his history or anything. I'm not sure he was all that affable, okay? But he wrote good music, okay? Fantastic music. But just like today, even back then, music taste changed just about with the wind. And for a long time, the symphonies and the string quartets and all these things, that was the thing. And the music people got a little tired of it, wanted to go to something more modern, you know, and stuff. So as Beethoven was getting older, even though he was one of the greatest conductors who had ever written, his music sort of went out of style. And back then there was no Social Security, there was no 401ks or anything else. He lived on what he wrote. And people just weren't buying it anymore. So he got poorer and poorer, more destitute. And if my memory's right, he also was going deaf, which is sort of a bad thing for a musician, right? But he knew music inside out. So what he did, he was quite a pianist too, and he composed on the piano. And he cut the legs off of his piano so it sat right on the floor. He squatted on the floor, and I don't think he was a little dude either. And that way he could feel the vibrations. Boy, talk about a 10 o'clock scholar. Okay, all right. Dakota's here. Good to see. We're in a dumb story mode. Sorry about that. Okay? So he actually cut the legs off his piano so he could feel the vibrations to see if it was sounding right, but he was feeling it. Incredible, incredible musician. Okay? But dirt poor by the end of his life. And he was living in some shack somewhere, a landlady, you know, and stuff, all this kind of stuff, and he ultimately died. And, you know, They discovered the body sometime later, you know, and he had no money. They didn't know of any family. So they just buried him in what they call the potter's field, the pauper's grave, okay? And so they just dug a hole, put him in. That was it. She probably didn't give a whit of what he had written in the past, you know. She may not have even known. Who cares, okay? Later, there was sort of a musical revival. People got tired of that new style of music and said, man, this just isn't as good as Beethoven's stuff. Well, whatever happened to Beethoven? So people started looking around saying, where is Beethoven? Where is he now? Has he written anything new? And then when they researched and kept digging, they found out he had died destitute and had been buried in a potter's field somewhere. They said, this will not do. This guy was one of the greatest musicians who's ever lived. We've got to honor him. We got to move him out of the potter's field into a respectable cemetery and put a mausoleum up and a name, and so people can come and remember him. So they had to go through all the, and this was in Germany, I think it was, so all the legal ramifications of exhuming the coffin and that kind of stuff, and they got it all done. So that night they were out there digging him up and stuff, and the poor guys, they lived, and he was no wee man either. They picked him up and stuff, and dropped him, and the lid popped up. And there he sat with sheet music in front of him, just racing like crazy. What was he doing? Decomposing. Never mind. Okay. All right. That was our dumb story of the day. All right. So, let's move on to an application. And we've got time for it. Boy, what perfect timing. All right. Here's an issue. The number of bacteria in a refrigerated food, this is in the fridge now, is given by this. N is a number, T is a temperature. Capital T is temperature, usually given in Celsius, degrees Celsius. Okay? And you remember, okay, in a refrigerator, it's not freezing the food, it's just keeping it pretty cold. So if that temperature is, this is a refrigerated food, and the refrigerator keeps the food around 2 degrees Celsius, which would be about 35 or so Fahrenheit. Okay? Maybe, close, about 35 or so Fahrenheit. Okay? Which is about right. Check Mom's refrigerator at home, you'll see that usually the setting somewhere around there. Okay, so you pull it out of the fridge, and it's going to start warming up, right? Now, does anyone know what room temperature is in Celsius? Any of you lived in another country that uses metric? Okay, it's about 20 degrees Celsius. So this is warming from the 2 degrees it was in the fridge to close to room temperature. And as it warms up, the number of bacteria grow, okay? And they grow by this formula. By the temperature, as the temperature warms, number of bacteria grows. Now, this isn't a fair question to ask. If that refrigerator took it down to 0, then there would still be 500 bacteria in it at 0. They only took it down to 2, so it's already starting, well, we won't go there. But anyway, there's some bacteria always there. But T is the temperature of the food in degrees Celsius as you pull it out of the fridge and it starts warming up. When the food is removed from refrigeration, the temperature of the food is given by, and this is how the temperature increases with time, as it moves from 2 to 14 degrees. The temperature is a function of time. Capital T temperature, little t time, is 4T plus 2. So if you pull it out at time t equals 0, what is your temperature? 2, okay? Well, that's what it was coming out. And then the longer it's out, the warmer it gets, and the warmer it gets, the more bacteria grows, right? Okay. And this is good from t equals 0 to 3. Well, let's see what happens at 3. When t is equal to 3, this would be 12 plus 2 is 14. So this works, okay, for these domains and these ranges, where t is the time in hours, okay? Find the composition N composed with T of T, and interpret its meaning in context. Ooh, okay. What would N of T mean? You tell me. What would be that definition? Y'all did it before. Second. N, parentheses, T, capital T of little t, close. Okay? All right? Find it. That would be N of, you do the innermost first. What's capital T of little t? 4t plus 2. Okay? And now what do we do with the capital N function? You start with 20. 4t plus 2 squared. Whatever is in that parentheses here is squared. Got it? Minus 80 times 4t plus 2 plus 500. All right. That's pretty exciting, doesn't it? All right. So let's do that. Let's jump up to here and do that. That would be 20 times, you got to square 4t plus 2. Can anyone do that? 16t squared, that's right. Plus 16t plus 4. Okay. Minus, can you do that next one? 320 little t minus 160. Does everybody see what he's doing? Okay. Plus 500. Okay. We got to clear that first set of parentheses. What does that give us? 320 t squared plus, that's the same thing. That's, yeah, 320t plus 80 minus 320t minus 160 plus 500. Okay, I know this is messy. I just don't have a lot of room. But what's a good thing you see? Plus 320t minus 320t add to 0. Okay? Now, I think that's not an 8 there. That's an 80. I didn't write down my 0. Sorry. Okay? Now, so let's go up here. This will be 320t squared. And then combine those. 580 minus 160 would be 420? Okay. Plus 420. All right. So this is your N of T of T. That's what we were asked to do. That's what we got. And interpret that for me. What does that mean? What does N represent? Number of bacteria as a function of time. The times that you pulled it out of the fridge. Only good for the first 3 hours. Okay? Now we can look at this. When you first pulled it out of the fridge, how many bacteria were in there? 420. Those T is equal to 0, right? Okay, 420 bacteria. They started that. Okay? Now, you know, we eat bacteria all the time. You don't think about it, but you do. Your stomach's full of some really, really, really strong acid. It kills just about all of them most of the time. But when you get an overdose of them, and your stomach doesn't quite get them all, then you're in, I won't say deep something, we won't go there either, okay? It could be pretty serious, okay? So, but the longer you have it out of the fridge, let's see what's happening there. Okay, so if you interpret it, the meaning is the number of bacteria as a function of time out of the fridge. Now it says, find the time when the bacteria count reaches 2,000? Yeah, you just plug it in that thing. the count is 2,000. That's your n of t. So you do 2,000 is equal to 320 t squared plus 420. How do we solve that? Subtract 420 from both sides. 1,580 is equal to 320 t squared. Divide by 320. Okay. So t squared, let me find someplace right. T squared is equal to, anyone got a calculator? I don't want to do all that in my head. It's too late. Anyone got a calculator? Punch it in. Say again? 1580 divided by 320. Or 158 divided by 32. I don't care. Say again? 4.9. And take a square root of that. Oh, it won't. Shame on phones. Okay. Any guy want a calculator maybe? Square root of 4.9. Nobody has a calculator? Say again? 2 point something. How about that? Okay. All right. We'll look in the book. They probably have the answer there. Say again? About 2.2 hours. Okay. In 2.2 hours, you're up to 2,000 bacteria, starting from 420. Those little babies can grow, can't they? Fast. Okay. That's why Mama says, put that food back in the fridge. Are you through with it? You know. That's why she wants to limit the number of bacteria growing there, right? I think Thanksgiving meals when no one wants to put up anything, my mother-in-law, get that food in the fridge. Get it off that turkey bone. Yeah. Get it in the fridge. Otherwise, those little buggers are growing. Okay, good. Let's see, is that the, here's they show it. Okay, let's see if we did it right. Looks like everything looking all right. 320 t squared plus 420. Now set that, and that is the number of bacteria as a function of the amount of time the food has been out of refrigeration. Very good. When it's 2,000, set that equal to 2,000, 2.2 hours. Very good. Note that when you solve the equation, you reject the negative value, don't you? When you take the square root of both sides, you should have said plus or minus. A minus time makes no sense, so you throw that one away. Use the positive. All right, homework exercises here. We'll begin next time. Do y'all find the vocabulary useful or not? You want to do it or not next time? Tell me something. No? Okay, we'll start with 1.9. So homework exercises, do number 3. Do any of the odds 5 through 11. 11's on calcview.com. All the odds are on calccheck.com. Do any of the odds 13 through 23. 13's on calcview.com. Do either 25 or 27. 25's on calcview.com. Do any of the odds 29 through 33. 33's on calcview.com. Do any of the odds 35 to 41. 35's on calcview.com. Do 43. It's not on CalcView, but it's on CalcCheck. Do either 45 or 47. 45's on CalcView. Do any of the odds 49 through 55. 49's on CalcView. Do any of the odds 57 through 63. Okay? And the rest of them are up to you. You can do any of the rest that you want to. We'll start next time on 1.9. Any questions? Okay, we'll see you Thursday. And that means if we finish 1.9 Thursday, that means we are ready for the test on Tuesday. If we don't finish 1.9 on Thursday, the test will probably be. Yeah, you need to get the quiz back to me before it's test time. Right. So, yeah. So get me the quiz back as soon as you can. Yeah, if you got it, I'll take it. A little hot. Okay.
You'll take it Thursday.
What's that?
You'll take it Thursday.